Okay, in this video, we're going to talk about another idea, another feature of the C++ language called operator overloading. And it ties into our complex number class. And I'm just going to give you some brief introduction to it this week. And then in some later weeks, we're going to build on this more. So operator overloading, what is it? So if you think about our complex number class, wouldn't it be a better abstraction if instead of calling this add function, we could instead directly use the plus operator? And we could say, well, I have an object j and an object x, and let's just say x equals x plus j to add the two objects together and create a new value for x. You know, wouldn't that just be far cleaner and more intuitive? Well, the good news is with operator overloading, we can do that. We don't need to write this kind of clunky add function that we add into the object and have to call explicitly. Instead, we can just use the built-in operators, but we can't use them yet. We have to do a little more work to get them to work, to make this function properly. Okay, so operator overloading is kind of like function overloading. It lets us change how operators work when they're used in new contexts, specifically when they're used for objects that we create ourselves. And operator overloading is supported for many operators in C++, like addition, subtraction, multiplication, division, excuse me, shift, assignment, less than, greater than, and so on. Okay, and most of these operators can be implemented in a similar form as operator equals that we've already seen, which probably looked like a weird special case to you before, but actually operator equal is just one of the many operators that we're allowed to implement. Operator equal is a special member function, so it has a special place in the pantheon of operators, but there are all these other operators that we can also overload in the same way and use in our code. And for complex numbers, it's just incredibly helpful if we can override things like addition and subtraction and multiplication and division. So what we do is we can replace that add function that we've had in here with operator plus. And the way we do that is we just get rid of the name add and we replace it with operator plus. And then this plus operator is going to work on two objects. One of the objects is being passed in as an argument. This is the object that's on the right side of the plus, it's the j. And then the other object that we're adding is the object that this is called on, that the plus operator is being called on, which is the x object. And so we're going to add x and j together. And then this is going to return a new object that we create inside this member function. So we make another complex variable n. N gets the addition of this object plus the right side object of the addition. And n will then contain the sum of those two objects and return a copy from this function. Here's another look at the operator plus, right? If I have objects A and B and C, then operator plus is going to get called on the A object. B is going to get passed as an argument. A way we could write this out in long form, and this is perfectly legal to do, you can say A dot operator plus and pass B as an argument. And that A dot operator plus B is exactly the same thing as writing A plus B in the code. Okay, now the plus operator does not do the assignment to C. That is the assignment operator that we've already talked about. And since, and as we talked about with the rule of zero, for complex numbers, we don't need to implement this assignment operator ourselves. The compiler does it for us. And so really, this object C has kind of a implicitly defined operator equals that'll then do the extra work of copying the return value of operator plus into object C. So we could write this whole expression out in long form as C dot operator equals, and then it takes as its argument A dot operator plus B. Fortunately, it's just a lot better and a lot cleaner to write C equals A plus B. Just making a little more sense of what this member function, how this member function is declared. A member function for addition, it's going to take an object of the same type as an argument. So this is another complex number we want to add. And the const just means we promise not to change this inside our addition function, which is a nice thing to promise. It's not required, but it's a good thing to do. We don't have to make this a reference. It just makes it more efficient. It means we're not making a copy. But you could omit reference here. So all you really have to say here is complex RHS, for example. The plus symbol here means we're overriding addition, but you could replace this with subtraction, multiplication, division, and so on if you wanted to implement something different. And then the return of addition is another complex number. And that's because, you know, when you add two integers in C or C++, it produces a third integer. It doesn't change one of the integers you are adding. And so we need to adhere to that logic, otherwise it'll confuse programmers, right? So when you do addition, you don't change the object you're doing addition on. You create a new object that holds the result of the addition. There are some restrictions on when you can do operator overloading. You can't use an operator in a way that violates the syntax rules for the original operator. So you can't, for example, turn a binary operator like addition into a unary operator. And the precedence rules for the original operator still hold. So you can't, you know, make addition more important than multiplication in an expression. Multiplication will still have higher precedence even when you overload the operators. Okay, binary operators are assumed to happen, you know, to the left side object always. By binary, I just mean an operator that has two operands, like addition, subtraction, multiplication. It always happens to the object on the left, and then the object on the right is passed in as an argument to the overloaded operator function. You can't create new operator symbols, unfortunately. We can't extend C++ to have brand new operators. It's too bad. There are other languages that let you do that, like Swift, and some others, but we can't do that in C++. Also, there are some operators that can't be overloaded. You can find a reference to that in the book on page 573. So I just want to touch back to its relationship on some of the key ideas we've been talking about, encapsulation and abstraction. So encapsulation is illustrated here by the fact that the overloaded operators are added to a class to provide useful functionality, right? We're actually adding addition, subtraction as overloaded operators into the complex number class, and it's part of the class. And so that's this example of having functions and data together to make using objects easier. And so that's encapsulation. And then abstraction, it's an example of abstraction too, because overloaded operators allow objects to be used in expressions like primitive types. Like I can just say A plus B. And that hides the fact that I'm really calling that operator function. And I don't need to write out the call to that function. I can write something simpler and get the same effect. And by writing something simpler, I'm hiding that function call. And so that's a kind of abstraction as well. Okay, so in summary, in the same spirit as function overloading, we can overload operators to work with new objects. For the complex number, some operators that make a lot of intuitive sense would be like plus, minus, multiply, divide. Most operators can be overloaded with the same restrictions and precedents they have on primitive types. And overloaded operators are just another tool we have in C++ for creating effective encapsulation and abstraction.